In this video, we will learn about the exponents of real numbers. So, if a is a real number and if it is multiplied by itself n number of times, then we can express it as a raised to the power of n. So, what do I mean? So, if a is multiplied by itself n number of times, this can be expressed as a raised to the power of n, where n is called the exponent or power of a. So, for example, 2 multiplied by 2 multiplied by 2 3 times is represented as 2 raised to the power of 3, also called as cube. 3 is also referred as cube. And similarly, 4 multiplied by 4 is represented as 4 raised to the power of 2. 2 is called square. So any real number raised to the power of 2 can be also called as its square. Similarly, any real number raised to the power 3 is called cube of that number. Any other numbers, for instance, 5 times 5 times 5 times 5 times 5 is simply represented as 5 raised to the power 5, and it is called as 5 raised to the power 5, or sometimes in short called 5 power 5. Now let us talk about some basic identities of exponents. If a is a real number and if it is not equal to 0, then a power 0 is equal to 1. Similarly, 1 by a power n is equal to a power minus n, where n is a rational number. There are two other identities that we have to remember. If a power m is equal to b power m, then a equal to b. Given a comma b belongs to R, a is not equal to 0, b is not equal to 0, and m is a rational number. Similarly, if a power m is equal to a power n, then m equal to n. Given a belongs to R, a is not equal to 0, and m and n belongs to rational numbers. So these are the four basic identities that you have to remember. Next, we will discuss some of the laws of exponents. The first law of exponent that we will talk about is called the product of powers. So if a is a real number, then a raised to the power m multiplied by a raised to the power n is equal to a raised to the power of the sum of the exponents m and n. So it's a raised to the power m plus n. So let's try to prove this. So let's start with the left hand side. So the left hand side is a raised power m multiplied by a raised power n. Let us expand the left hand side terms. So the first term is a raised power m. So it's a multiplied by a, so on, m number of times. Similarly, let's expand the second term, a raised power n. It is a multiplied by a, n number of times. So if you combine the two expressions, you end up with something like this, where the number of a's in this expression is m plus n. So as we have seen in the previous lesson, any real number multiplied by itself n number of times could be expressed in the form of a raised power n. Here the number a is multiplied by itself m plus n times, so we can represent that as a raised to the power m plus n, which is your RHS. So for example, 2 raised power 3 multiplied by 2 raised power 2 is equal to 2 raised power 3 plus 2, which is 2 raised power 5. We can verify this. 2 raised power 3 is multiplied with 3 times, and 2 raised power 2 is multiplied 2 times. Here 1, 2, 3, 4 and 5. There are 5 2's in this expression, which is nothing but 2 raised power 5. Similarly, you can take any other expression and this identity will still remain the same. For example, 4 raised power 10 multiplied by 4 raised power 20 is equal to 4 raised power 10 plus 20, which is equal to 4 raised power 30. The second law of exponents that we will learn is also called power of power, which is if a power m is raised to the power of n, then it is equal to a raised to the power of product of the exponents m and n, which is a raised power mn. So let's try to prove this. So consider the left hand side, a raised power m raised power n. So which is equal to, if you expand this, a raised power m multiplied by a raised power m, so on up to n times. So from the previous law of exponents, we learned that a power m multiplied by a power n is equal to a power m plus n. So if you observe this expression, it is in the form of a power m multiplied by a power n, which is in this case m. So we can write this expression as a power m plus m, the first two terms, multiplied by a power m, so on to a power m. So if you apply the same formula to the first two terms, you will now get a power m plus m, so on to a power m. So if you continue applying this formula, you will end up with a power m plus m plus m plus m, so on to m, and the number of m's in this case is n. So this is nothing but a power m multiplied by n, which is equal to a power mn, which is nothing but your RHS. So for example, 10 raised power 3 raised to the power of 4 is equal to 10 to the power of 3 times 4, which is equal to 10 raised power 12. In this way, you can apply the power of power law and simplify complex expressions very easily. The third law of exponents that we will learn is called quotient of powers, which is if a raised power m is divided by a raised power n, then that is equal to a raised to the power of the difference of exponents m and n, which is m minus n. So let's try to prove this. So consider the left hand side, a raised power m divided by a raised power n. So let's expand the numerator. This is a multiplied by a multiplied by a m number of times is divided by a multiplied by a multiplied by a n number of times. So the numerator can also be expressed as a multiplied by a multiplied by a, so on n times, multiplied by a multiplied by a multiplied by a, so on to m minus n times. This is because, so we totally had like m number of a's in the numerator, but we took out n number of a's out of it, and then the remaining would be m minus n number of a's. So this is how we can express the numerator. Now divide this with a multiplied by a multiplied by a, so on to n number of times. So these two terms get cancelled out, and you will have a multiplied by a multiplied by a, so on to m minus n times, which is nothing but a raised power m minus n, which is equal to your RHS. For example, 5 raised power 6 divided by 5 raised power 2 is equal to 5 raised power 6 minus 2, which is equal to 5 raised power 4. We can actually verify this as well. So if you expand the numerator out, it is 5 multiplied by 5 6 number of times, and if you expand the denominator, it is 5 multiplied by itself 2 times. So if you cancel out the terms, you will be left with 5 multiplied by 5 4 times, which is nothing but 5 raised power 4.